Thank you all for being here. Good morning, good day, and good afternoon, depending on where around the world you're watching this from, and welcome. I'll just quickly introduce the people that I have with me for today's webinar, which is quite a crew this time. So we have a lot of people here that are going to talk about something. So bear with me while I introduce everyone. Most of you might know me. I'll be hosting the webinar and introducing everyone and interacting with you throughout the course of this webinar. My name is Dan. I'm a sales team member here at SIBA, and I mainly do these webinars as well. Some of you, most of you that have watched our webinars before might be missing someone. Jesse van Dongen, our Learning and Development Manager, who is normally our moderator, is on holiday this time. So we have Quinten, who is now replacing Jesse as our moderator. Quinten is a marketing member here at SIBA, and he will also be hosting or moderating this webinar. And then I have three of our in-house architects with me, Leo, Iro, and Thanos, who will shortly introduce themselves when we reach their part of this webinar, which I think is a nice way to do it. So, for the people that don't know about our webinars, we do these webinars every month. We had our 10th one, I believe, last month, so this is the 11th one that we are doing. Or maybe a 12th one last month. I don't remember. We've done loads, and we've done them live, but since most of you might not have seen all of them, you can also watch them on our website in our library, and they're also posted on YouTube. So if you miss a part of this or you don't have time to watch the full extent of the webinar, you can always watch it later. Like I said, we have our moderator Quinten here with us, who will be in the chat answering any questions. So if you do have any questions during the webinar, please do ask them in the chat. The architects that I have with me will also be in the chat answering questions. Some of them might be a bit too long to answer in the chat directly, and we will address those at the end of the webinar, where we always have a Q&A where we will all be on screen answering your questions. So the content of this webinar, of this month's webinar, we'll be talking about some projects that we have done in the past and what we've learned about them. So first of all, I will shortly introduce SIBA, our mission and vision, and how we work on those two. For the people that don't know yet, after that, we will talk about 3 different projects, and every project will be discussed by one of these architects that I have with me this month. So first, to start off, of course, we have Quinten. He's from marketing, and he would love to know which of his messages that he posted did you read, did you see? So where did you hear about this webinar? We would love to know if you could answer that for us. I believe you can do that below the slide in the poll. Let's see, via mailing. Yep, a lot of people via mailing, social media and mailing. So it looks like mailing is the winner here. Yeah, I had those mails in my inbox as well. They're hard to miss. So good job on that one. All right, thank you guys. Let's get started with the rest of the webinar. So a short introduction about who is SIBA. Most, if not all of you, might know who we are and what we do. We've been around for 10 years, but I'll shortly reintroduce our mission and vision and how we focus on those two, because it's relevant for the rest of the information that you will be getting today. So our mission is, of course, being a global innovator in the 3D construction or overall construction sector. And we would like to be the innovator of material, hardware, and software that is needed to build faster, cheaper, and more sustainable, which is also, of course, like I said, our main mission. So we do build 3D printers, but that's not all we do. We come up with technologies to build faster, more affordable, and more sustainable. And the vision that we have as SIBA is that we would like to solve a lot of big problems in the construction industry, a lot of housing shortage, high construction costs, material costs, supply chain problems. And we think that by attacking these problems in a global and holistic way, we can solve a lot of these problems. So by defragmenting the construction industry, but thinking of it as a holistic thing, and working on that, we can solve these problems. So that's what we focus on. Well, I've told about building faster, more affordable, and more sustainable 100 times, I believe. And normally when we talk about this, we talk about that we print very fast, that our material sets very fast, that we have less labor cost, of course, by printing, less overhead costs. But this is all building related, construction related. But before you start building, there's actually a big part of design and engineering that also takes a long time. Architectural drawings, conceptual, technical designs, permitting. We've talked about the construction side of things a lot, but today we'll mainly be focusing on the pre-construction part of it, like how can your architects and structural engineers improve their process using our solutions to also shorten the pre-construction phase, which is what we'll be talking about today. Another short poll, because we are interested in this, because these are the projects that we will be talking about. Have you heard about the projects that we have done in Curacao, Paraguay, and South Africa before? Or have you heard about any other projects that we've done? I believe the first project that we will talk about is the one in Curacao. I believe that's the earliest one. That was 2019, 20? 21. So all quite recent projects. We've done some more. Never heard of the projects, more than one. If you have heard about another project that we've done, please put it in the chat. We would love to know. All right. Perfect. So we'll start. The first showcase is the Robust Villa, and for Robust Villa, I brought Iro with me. Iro, if you can enter the webinar. I'll turn off my microphone and sound. Your sound as well.
No.
Let's see. Is the echo gone? No, it's not. Now it is. Yeah, there we go. Sorry, guys. So the first showcase will be Robust Villa, the project that we did in Curacao. I'm very curious. Take it away. Tell us what you know about this project.
Sure. Thank you, Dan. Hi, nice to see you all. I'm one of the architects, the in-house architect. So I'm going to talk about Robust Villa a little bit. It was indeed a project from 2021 in Curacao, around 100 square meters. It was printed off-site at the end, and there was no requirements for insulation. And also, like, one of the main points here is that it was our first LIV project that was actually printed for a partner.
Yeah, and the LIV projects are the projects that we design in advance to be later printed by our partners, right?
Yes.
Thank you.
So if we can start with the concept of the building, it was a concept that we developed in order to make it easier for us, the designing team, and also the printing operators to realize a project with a building that could consist walls of the same shape, sizes, and take advantage of the robot range the most. So a more efficient shape, and multiply this wall many times to create our building. It was initially we had it on the LIV website with not many features, but still the client could already change some parts according to their needs. But later we had the program of requirements, a specific one from our partner in Curacao, with a sketch and how, deciding together how we could change that floor plan in order to accommodate every of their requirements. Some of them were to change the size of it, adapted to the 100 square meters, and also changed the function. Before it was a villa, and after that we had to make it a cafe, so change the configuration of the interior as well. Later, in the conceptual phase again, we had to decide together with a partner the strategy, the printing strategy. So in that project, a requirement was to have as less conventional work as was possible. So print most of the walls, most of the elements. So we integrated the lintels with the walls. We created 13 walls that we would print, and also we developed a structural system with our structural engineers from our company. And after we finalized that, in always collaboration with the partners there, we had to go to the technical phase.
Yeah. So you went from a design that we already developed or designed, then you went to the customer in conversation with them. You changed this already existing design to their function.
Exactly.
Changed it to a nice conceptual design. And once that was agreed upon, you went to the technical phase,
yes.
Which is this one. All right.
So yeah, in that phase, it was the first time, like we did a lot of tests, and it was the first time that we used the concept that we were developing of the 2-layer system. So before we were using the 3-layer system, as you can see at the left side of the page, which was safer because we knew that it was stiffer, but we wanted to have less material, less printing time, so that also minimizes the costs.
Yeah.
So after some tests, we decided, the partner also agreed, and we decided that it's stiff enough to use the 2-layer system, and we started with that, and it was successful, so we use it also for the rest projects, as you will see.
Great. Yeah.
Also, like we had to define the wall anatomy, how we could split the wall from bottom to top. We had the infill at the bottom, as you saw before, and then we needed to have one cavity for the beam, so that it is continuous.
Yeah.
Without the infill. And then on top of that, we decided during the structural system that it will be reinforced concrete for the beams, the columns, and also have a formwork for the slab, which would also be reinforced concrete. And we had a formwork printed at the side of the slab, so at least we could minimize some of the manual work and make it easier and faster for the partner.
Okay, so we used the infill in the walls themselves to build the columns.
Yes.
Then on the top we made a design for the ring beam,
a continuous beam,
formwork
exactly.
for the ring beam, and then also some wall principles to connect the slab to this ring beam.
Extend a bit the wall so that we have the side of the slab already there.
So that would then
no extra
replace the work for formwork.
Exactly.
All right.
Exactly.
So that decreases, and that's already determined in the design
time
phase.
yes,
Yeah. All
yes.
right. Right.
And make it easier for them. About the printing sequence, it was a simple wall because it's really spacious, so we had enough space, and it was easy to decide exactly the positions of the robot inside the building.
Yeah.
Only thing it was an extra was the last element that we had to extend a little bit the slab there, so we could take the printer outside of the building, so it's not trapped inside, and print the last element from the outside.
Yeah, you don't want to print your walls around your printer because that's a very expensive building if you can't get your printer out.
Yeah,
so
exactly.
This was planned to be print on site, but eventually some changes were made to print it.
Yes, I will come on that.
Exactly.
Exactly.
Okay,
yeah. So during the operational phase, it was everything prepared to be printed on site, as we said. Create all the documents with the position of the printer, the dimensions from origin to printer to element, all the coordinates for the points of the corners of the elements, and also all the additional elements like the support for the lintels, the support for the slab formwork that we said before, and the support, the bottom formwork for the beam.
Okay.
A timber plate for that. But then indeed, when people like our printing team was there, because of some logistics and scheduling changes, they had to print offsite in a factory. So thanks to our tools and our collaboration with the team there, we were able to change immediately some of the models. So to split the wall from the lintel, so it was better for transport them. And as you can see there, like all the process, they start printing there in the factory, and then transport them on site, hoist them with a crane, and place them at the final locations.
And how long
Separately,
was that process, the change from on-site printing to off-site? It was done quite
For
quickly.
you mean the documentation? It happened while they were there, so it had to be done quite fast.
So, but this is because of the tools that you and our team
Otherwise, it would take weeks.
Make changes very quickly. And that makes us flexible and fast as well, right?
Exactly.
Great.
So you can see the building, how it is from the outside, all the finishings, the slab, the windows and doors, how it's now. And also from the inside, you can see like some of the walls, our partner chose to plaster them. Others are left with the printing texture. And also you can see the outlets openings that was not initially in the design. We didn't consider them back then. And they had to drill them after. So that was something that we needed to improve. And we did indeed in the rest of the projects.
Understood. So first we just printed and then we drilled walls for the electrical conduits.
But it wasn't that efficient. So now, because it's possible, we include them, we integrate them in the design.
So we design in such a way that after printing you don't have to do anything to the walls.
It's already there.
And this is not a bad looking building for something that was completely changed in the final stages, right?
Indeed.
Props to you guys, schools.
Thank you. And also our partners there, they printed another live concept that we also engineered, and they already finished that building. And I think they're planning to print more similar or also other concepts there.
Correct. I believe they are now planning to build multiple houses based on these concepts.
Exactly. Yes. And we learned some lessons from that project. Most of it was the 2-layer system that it was successful, and we kept in the next projects as well. Since we are also using 25% less material, it's very beneficial for us in terms of time and costing material wise. And also we could say a better final look, better aesthetics at the end, smoother toolpath. Also, we added at the corners, we start rounding the corners at that project, but we had to explore it more, to develop it more, those guidelines. So we did it in next projects. Yes, we said about the openings for the electrical boxes.
Yes, exactly.
And finally, another one that was about our live projects and how we include all the features in the website, that we added more. So the client now is able to change more things by themselves and adjust the walls, like move the wall, for example, in this project to the X and Y axis. And it's possible to increase a room according to their needs. Then download the documentation and the 3D model. And then they already have a drawing, a floor plan with the dimensions and the square meters, and also some extra details.
This is something they can download out of the library, right? So they can change parametrically change the designs to their liking, and then download this document.
Exactly.
And that saves a lot of pre-construction work, right? For our clients, that of course this library is integrated or included in the purchase of the printer or included in a partnership. And then if you want to do another building, just change it parametrically and you have your conceptual design
already there. So you can skip some steps.
Exactly. So that really helps in pre-construction. I've got a quick question, which we won't do at the end, but we'll do it now. What do the orange or black walls represent in the drawings? If you can go back, I believe, 1 or 2 slides. Let's see. Right here, for example, the orange walls
are the interior ones. So it's optional if the client wants to print them or not.
Yeah, so those are interior walls, so not structural, not necessary for beams and columns.
Not always. So it's up to them mostly. We can do both.
Hope that answers your question, Mike. So question for you, we talked about 2-layer versus 3-layer. Like Eo told us, very big optimization even during the process. We're wondering what you guys think about the 2-layer compared to the 3-layer system and how that went. And then while we're waiting for some answers, I'd like to reiterate that this is also why it's quite hard to make a realistic cost estimation, because we start a project and then we can give a conceptual cost estimate. But as you can see here, we decrease material use even during the technical phase or conceptual phase, technical phase by 25%. So the high level cost estimate is very rough, and usually in every design there's quite a lot of room for improvements, right?
Every time, yeah.
So something to keep in mind when planning on 3D printing a building. It's not just about the material, but also how can I design my building to be efficiently 3D printed. Let's see, so low material wastage, correct, lower production time, of course, and therefore lower cost. Reduce wall thickness, indeed, not so much, right? Because that's more dependent on the distance between and not the amount of layers. But the overall thickness decreases.
Yeah, it could help with minimizing the wall width, but yeah, it gives an extra option.
Yeah, it's not the main point of this design choice, right?
Exactly.
All right, great, thank you. I believe we will then talk about microphone was gone for a second. So now next we're going to talk about the building that we did with the University of Johannesburg, and we will do that together with Leo, who's right across from me.
Hey, hello everybody. I'm Leonardo, another one to the my team of the architects and designers here at CIBE. Today I'm going to be telling you some things about this project. We worked together with the University of Johannesburg last year for like January and February 2022. So let's start. So the main points about this project is that we already got from our partner a quite advanced conceptual design that you can see in the small floor plan on the left side. So already we had some requirements. It was a one-story house, a typology really similar to traditional construction in South Africa. And the goal of our partners was as well to compare the speed of our new system with that of traditional construction. So a series of other requirements that we had to incorporate in our technical and operational design phases, where the fact that, of course, we needed to do the minimum amount of modifications to the original design, at the same time provide advice on structural design aspects. We didn't need thermal insulation because of local climate, and this influences a lot the wall system decision eventually. And then, of course, we had to design this building in the sense that we wanted to maximize the speed of construction, but also optimize it for on-site printing, because this building was realized during one of our 10 days training.
Yeah.
So basically the conceptual design, what we did was starting a series of regular meetings with our partners and all the stakeholders involved. And what we brought to the table was our parametric approach. So what we did basically was translating the floor plan that I showed before into a parametric model that allowed us to quickly iterate with the partner, saving a lot of time in those meetings, and in order to discuss topics such as the thickness of the walls, their height, the inclination of the roof, for example, and other topics as well that we needed to agree upon. Topics such as those that you see in the bottom of the slide. For example, we had to discuss the position of the openings, because of course we didn't want to change the design, but we realized that if we could push the openings a bit to the corner of the wall elements, this would allow us to reduce the amount of walls that we needed to print with our robot. So already in the conceptual phase, we had to start understanding how these wall elements will look like and how we could split this design into a series of printable walls.
Yeah, but those changes were quite easy to do due to the tool, right?
Yeah, exactly. You already have the parametric model.
Yeah.
So real time, we could just discuss both internally and with the partners. We could just play with the different positions and provide a ready estimate of them, because based on average data of how much time it will take, how much material it will take.
Yeah, so you don't have to go back and completely overhaul
No,
it. You can just
the model is one, just different iterations on it.
Great.
And at the same time, another topic we had to discuss was the wall system. So of course, we didn't need installation. We took what we learned with Eero and the Robust Villa, and we built on top of that. So we discussed different possibilities for the two-layer system. That then, in the technical phase,
One second.
Yes,
Aaron.
sure.
I see a couple of times in the chat that people can't interact with us or see the chat. If you are in the interface of the Geek Webinar Geek, sometimes compresses a bit. If you press Control and you zoom out on your web page, everything should come into play. So let us know in the chat if that works. That should be the solution. Sorry.
No worries.
Yeah.
I hope everybody is able to interact.
Yep.
But yeah, going back then to the technical design. So in the conceptual, we chose wall system. We decided to go again for the two-layer system without installation because it helps us saving a lot of material.
Yep.
What we needed to do was understanding how thick these walls needed to be. So the orange square you see on the drawing on the bottom left is one of the structural reinforced concrete columns. So in order to determine how big that was, we had to again develop, also in this case, with a parametric approach, a structural model where we could explore different grids, different layouts for the reinforced concrete frame and the 4 different dimensions. Once these changes were also discussed with our partners, are agreed with their local structural advisor, we could proceed with the other aspects of the technical design, such as agreeing on the many construction details. And this is extremely important to do in time, because of course we need our partner to understand the technology, but at the same time to provide on time the required materials. For example, we have to work on ways of connecting the interior wall with the external walls through the use of wall ties, but also figure out a detail in order to basically realize a continuous cavity on the top of our wall elements for casting the reinforced beam that we calculated with the structural analysis before.
Yeah, the same as with the robust Villa.
Exactly. Yeah,
right?
The detail is pretty similar. In this case, we don't have the slab
Of course.
part that you was mentioning because the roof has been realized with traditional construction. It's actually a steel roof eventually.
Yep.
But yeah, up to the ring beam, that's the same approach. Exactly.
Yeah. So, and this is a method that we often use because every structural engineer around the globe can calculate on beams and columns.
Exactly.
So it's easy also for a municipality or a township to permit this because they can also calculate.
Yeah, part of a lot of what we're doing, also making this understandable so for local authorities.
Of course, if you want to revolutionize something, it's very easy to come up with a massive change. But if you keep it as close to traditional as possible, it's easier to
step
take
by
people.
step.
Exactly.
Yeah.
All right.
The final part of the technical design was to take that initial segmentation I mentioned back in the conceptual phase and detail it more. So you see here part of the documentation we provide. We ended up with 13 wall elements, including also interior walls, which as usually happens, also as it happened for the Robust Villa, were initially excluded from the scope of the printing. But then you see how we define the position of the robot. So basically in all the circles, you see the center point indicates the center of our robot. And then we have to understand also printing sequence. It's really important. Eero stole my joke about getting the robot trapped into the building, so I cannot do it again, but that's a really important part of this process. At the same time, also, we don't want the robot to collide with already printed elements. So it's really important to develop this sequence properly. And this is something that you need because of the fact of the interior walls that were added in a later stage was actually quite challenging in this project.
Of course, it's quite a crowded building if you look at it.
It's not really spacious.
But not really. But if you look at the left picture, you can see the numbers, and you can see that we first did the left outside walls, then the right side, and then from number 9 worked backwards.
Towards the exit,
towards the building.
Wall 13. And actually, in orange, you can see highlighted the robot range for wall number 11, which was actually the main challenge of this project.
Oh, of course, because you have to fit it in the corner between 2 and 3.
And you'll see another picture of that.
Okay, understood.
Actually, this picture, because after defining the technical design, we moved to the operational design part, which is mainly a phase that is made also for our operators. So there a lot of communication needs to happen internally in order for us to provide them with the right amount of information that they will need on site.
Of course. In this case, for the operators, while we trained the University of Johannesburg, but in the case that one of our partners has already bought a printer, we will provide them with this strategy, right?
Exactly.
We can. at least. Yeah,
Yeah, of course. But this is something that needs to be good with the people who are going to be actually on site.
of course.
And part of it is determining, again, as for the robust VLAN for all the projects we're doing, a series of coordinates that indicate the position of the robot, but also the position of the wall compared to an origin point. So you see actually on the right, the full floor plan with a lot of these points indicating this information for all the wall elements, but on the left, you see it, the same information specifically for wall number 11. And if you look closely, you can actually see how tight that fit was in order to actually provide a safe spacing for the robot from the wall, but also like a position that will allow proper printing.
Yeah, but still cool to see that even though it's not a small machine, but it's not massive, so it's quite nimble and you can maneuver it even inside the building, which gives it a lot more opportunities than just a big
Definitely.
massive machine, right?
Yeah. So the second part of the operational design is defining the specifications of all the additional provisions that will need to be provided on site. You see here, for example, in red inside the wall element, the plates that needs to be there for casting the beam. But in purple, also you see some EPS blocks that, as we can also see in the picture C on the bottom right corner, is what we use and we place under the lintel of our print so that our printer can actually print on top of it.
Yeah, it's like a support material.
Exactly.
Yeah.
It actually is a support material. What we understood is indeed that when you vary from site to site, the availability of material changes. So if you actually see a picture of the final result from Johannesburg, you don't see any EPS. You see a lot of wood false work that was used because EPS wasn't available on site at that moment. And that was actually a very important lesson because it taught us also in the few next projects how to integrate in a more flexible way the specifications without asking for specific material.
Yeah, and I believe that Thanos also will talk a little bit about why we use this formwork and support material and not just stack different blocks on top of each other.
Pretty sure.
But we'll talk about that later.
So that was one of the lessons we learned for the future projects, together with many others, of course. Some of them were about coordinating and actually managing this process. It was really important from the beginning and really effective to have constant meetings, regular meetings with all our partners, but also it was really important to develop further our internal communication in this case, because of course it was a training, but in general, we'll see that those lines of communication could be extremely relevant to successfully complete a project. And then from our designer point of view, of course, we realized how relevant it is to take into account the printing sequence from the really beginning by defining clearly a program of requirements in the first step. But also we tested further our two-layer system that proved to be extremely successful again, and helping us to reduce a lot of material in the prints. And as Eero mentioned as well before, we kept realizing we couldn't do it in this project, but we understood how many more things, how much more information we can integrate in these wall elements. And this can be the case, for example, of electrical conduits or place for sockets to minimize work on site.
So, and this was, like you said, done during the training. Was it 10 days?
10 days.
10 day training.
So actually,
we trained the team of the University of Johannesburg, and during this training, the practical part of the training, we actually used these wall elements to train them on these elements as well, right? So after this 10-day training, they were trained, certified, and they had a building.
And in 10
days.
Yeah, that was pretty fast. And also in initial plan, we didn't have to print the interior walls because we were thinking, okay, to be a bit on the safe side for these 10 days. At the end, we also managed to print those.
That's amazing.
Even faster than expected.
And that's all due to good preparation, good documentation. So they knew on site in those 10 days exactly what they had to do because all of that was thought of beforehand, right?
Yeah.
That's amazing. Great. All right. Well, I shortly did a recap of what was important, but I kind of spoiled this poll, but we are curious what you guys think is the most important takeaway from this project, especially in your own opinion, of course. Let's see. So indeed, increased experience with wall printing sequence. Well, of course, for us, it was important to get that experience to actually make the documentation. But if you decide to work with us, we will do a lot of that work for you. So you don't need that much experience. You just need to work together with us, and we will have that experience to write out such a document on the best printing sequence and all that, right?
Yeah, of course. All these projects in the end are adding up to each other. So the experience we get is a sum of all of this. And yeah,
every project done is a lesson learned, and I hope that will be like that for a long while, right? Knowledge on properly preparing printed walls for electrical and plumbing. Yeah, it's quite important that you at least know where you want everything so that we can change the designs based on that. Yep. All right, great. Thank you very much. Now we'll go to our last, well, not our last project, but the last project that we'll talk about for today, which is the row house that we did in Paraguay. And I will mute my microphone, and Thanos will join us as well.
Hello, everyone. I hope everyone can listen. Let us know if you cannot listen. My name is Thanos. I'm the latest member of the architecture team here at CIBE. And actually, this was my first project, printing project here when I joined the team about a year ago. This was actually a project that we didn't design ourselves. It wasn't an original concept from us. It was from our partner. It's a simple one-story house with a pitched roof that originally was designed to be a masonry structure. And what is important for this, it was printed during training as well. And the time frame was very short. It had to be done like the whole design and engineering part, all the adjustments to the design, the reports, everything had to be done within 4 weeks, which was only made possible because of the previous projects and all the knowledge and that we acquired from those.
Yeah. I have no experience with doing these design projects, but 4 weeks sounds like a very short time.
Yes. And one of the important parts was that we had a very good collaboration with the partners based on the printability requirements from us. But the main requirements from them were the minimal modification to the original design, because it was already permitted. It should be able to function both as a standalone and as a row house. And because there was a minimal use of material, because they need to print multiple of them and they didn't have a lot of material. So the strategy that we decided on the conceptual design for printing was to have a linear part and then a C-shaped part for the rest of the wall, so they can be repeated, and it would function both as a standalone but as a row house, as you can see in the diagram. The main issue there is what you see highlighted, that the windows on the right side are not of the edge, so that means it would require a small part of the wall, as you can see in the small diagram.
So you would have like the C-shaped in the top circle and then a column next to it.
A column next to it, or an O-shaped window, which something I want to focus later. But first, when we get a design, we need to segment it based on the printer range. The segmentation is something that, of course, is based on the printer range, but also there are other requirements, like the transportation requirements when it's off-site, when it's on-site, what is feasible there by hoisting, and also printability requirements. That's why, even though we have tools for initial segmentation and rough segmentation, the final segmentation is always done by us, because there are some other requirements that need to be met. And there are many advantages to reducing the element, namely less material, less need for sealing tapes on the joints, shorter printing and assembly time, which reduces the cost and improves the efficiency, and the increased structural stiffness.
Yeah, so
that's why in every project we want to optimize those parts.
Yeah, so the least amount of printable elements possible is normally the best way to go.
It's normally the best way to go, not in terms of material use. The material use is about the same, but increases the efficiency a lot because of the reduction in the time. When you need to print more elements, you need to wait for the element to dry, move it somewhere else. So this increases the time that you need to, the off time of the building.
So optimizing the design to decrease the amount of printed elements is important, right? Yeah. All right.
And that's why a small requirement for us that we want to discuss with our partners was if we were able to move those two window positions I showed before in the corner, so we can go from this O-shaped window to a C-shaped window. And it's just a small lesson on 3D printing and the material behavior. We prefer to print C-shaped windows because the O-shaped windows, as I show here, have these two risks. And the risks are shown here in the red lines, which is when we print an O-shaped window, you first print the number 1 part below the window, and then you continue with the number 2, next to the window. But while you're printing number 2, it means that when you go back to number 3, the part under number 3, the red line, that part, means that it has already dried a lot. So it's important to print wet on wet and not wet on dry. And the same happens in between number 2 and number 4, the part of the beam. We want to avoid those things because when you have this this case, it means that the wall is divided in many elements, and the behavior is different. With the environment, the temperature, there is thermal expansion, and when you have a C-shaped wall where when you print wet on wet, you don't have this issue, which means that the wall can function as one element instead of individual elements. And this is a big advantage of using our systems and our knowledge, because then you can avoid the cracks, as a lot of people have seen in other buildings. While with CB buildings, there are no cracks.
No, so the C-shaped design allows for a very easy continuous print, and the O-shaped design would, well, it's still one print-ish, but you would go from 1 to 2, and then once you start with 3, 1 would already be so dry that the connection between is not good anymore. That makes sense.
That is a risk.
Yeah.
And of course, it is possible in some ways, but we need to define it. We need to check it ourselves if it is possible in those cases.
Yeah, with the C-shape, it always works.
It always works.
O-shape
yes.
is just a bit of it can work, but it's harder to make work. Yeah.
So it was a small suggestion from us in the design. Of course, the partners understood that part, and we did this small modification in the design.
Perfect.
Moving on to the technical design, because in Paraguay they don't have requirements for a continuous insulation. The two-layer system that was developed in the previous projects it was utilized, and the only thing it would have to do was to facilitate the structural system. As you can see, the RC columns and the RC beams. So it was adapted to those requirements based on their own structural requirements in the code. And then when we go to the gable roof part, which is a different, it needs a different infill. For that one, we have 3 different suggestions based on the aesthetics and of the wall finish and the material. And since we needed to utilize as much material as possible, the third option was selected because it has the least print time and the least amount of material. With this option, because we have a continuous print, as you can see in the gable roof option in C, there are some where we have columns, there are some small triangles that are left out. But this is a problem when we have big inclination on roofs. When we have low inclinations, this issue is barely noticeable, so we're able to use this one in the selected option. And then the infill design was chosen, and we can go from the segmentation to the printable 3D model, which is used by the RC system in order to print. The next part is the slicing we use with chisel and the printing simulation. Then we can check that the build print code works as intended. And this is also important for safety, so we know that nothing unexpected will happen during printing for our operators.
Yeah. And in this GIF, you can quite clearly see why we like to use the C-shape method and not the O-shape, because with the O-shape, the robot, if you want to do wet on one, would have to jump between column 2 and column 3. For one, you would need to have a start-stop system, which is not standard on this model of printer that we use for the project. The other part is that you would have less quality because you have to jump from one to the other. And I don't know if people have plastic 3D printers, but you can get stringing and connection dots. And if you do a nice column in one go, one smooth toolpad, you have a nicer quality and a more effective and efficient print. So this is why we went for the C-shape design, right? So you can hop from one to the other, but it decreases efficiency. You need the start-stop system, and it decreases the aesthetic look of your print. So
yes, I hope that was because it's a lesson in 3D printing. So I hope we briefly managed to make our viewers understand that.
yeah,
If not, we can elaborate more on that. And then in the next phase, after the technical design is finished, we go to the operational design, which, as Eero and Leo already explained a bit, is about merging the digital to the physical space. Because when we make the models, we orient them based on the robot range in the 3D space, in the 3D software. But then going to reality, we need to translate those to a manual, and which is important for our operators on site to print it, but also because it was printed during training, also for the new operators that are here to be. But if also in the future, because they want to print this project again, want to make multiple prints, so they already have the manual for every time they want to print it. And the next part, the reference points, were about just assembling it on site, so they have the coordinates where to be placed on site. So in this page, we show a bit the guidelines that were defined based on the previous prints. As Leo mentioned, in order to have a continuous print, we require for the doors and the windows a false work in order to print the lintel part. And based on what is available, there were guidelines that were developed in order for it to be able to be done also with an EBS block or a timber frame. And these are all for every project. We define those.
Okay, so we can change the lintel system that the customer wants based on their requirements, right? So
based on what is available for them to manufacture,
of course.
They have the guidelines on that.
Right.
And also another thing that we need to define in the operational phase, of course, is the post-processing part of how to finish the wall, the sealing tapes for the air tightness. And also sometimes we require some support plates for casting the beam. This is optional because sometimes we use insulation. So insulation can also be part of the support for the beam. But if there is no insulation required, then we need some support plates. And also defining the cutout for the beam, so we can have a continuous ring beam.
Yeah, you can see here on the right. The right
we
picture,
can see on the photos, there are some on the top of the walls. You can see some parts that are cut out and will be removed before casting.
For the continuous ring beam.
In order to have the continuous concrete ring beam. And you can see here in the first image are the operators. They need to go inside the print range for a few seconds just to place the false work. So for safety reasons, it's important to always do these previous steps I mentioned, like with the simulation, with all the manuals, so they know for when the robot is printing on the other side for a few seconds, they can go in, leave the false work, and then go out of the printing range. So they're not close to the robot when it's printing.
Yeah, and we have supporting documents with some principles on how to do this and when to place the false work. So
at which height, at which point in time, so they're prepared beforehand.
Yeah. Right.
And of course, there are other safety measures like the dry test that they do sometimes before the print.
Of course, which is pretty much doing a print without material.
Without the material, just seeing the robot movement, so they're ready for that.
Yep.
And then the main lessons learned from this project was about improving our concept for a row house, because there was a row house in Live by Siebe concept. And then the technical design, this latest gable roof design was developed. And now that the two-layer system is a system that has proven to be working, it was an established system right now, so it was ready to be automated. So the infill design is currently being automated and done, not done with 3D software, but done with tools, which will be available internally first, but after that to our partners, so they can do it faster, and improved as well in our next projects based on the experience we've gathered in these projects.
Yeah.
And also the latest one in the operational design, that was also started as an internal tool for us, but now it's available to our partners in the library, so they can position their elements correctly in the 3D space, but also get the manual in the operational side of things to automate the documentation of that as well.
So all the lessons learned from all these projects and the tools that were designed, most of those tools are actually to be found in our library, also for our partners to be used. Right?
Exactly.
So lessons learned are not just lessons learned for us, but also experience that's valuable to our partners, of course. Thank you, Thanos. Quick poll before. Another quick poll before we go to the Q&A, I believe. Do you think we were right in pursuing our partners to switch their designs? So what Thanos talked about, we of course had a conversation with our partner to change the design, even though their initial question was not to, and we could not do it. But based on this, we again optimized the design. So what do you guys think about that? Very happy to hear that everyone would be open to having minor changes done to their design. One, no. So yeah, in general, some minor changes do take place. It's not to bully you. It's to optimize the design so we actually can save you time and money when designing for 3D printing. But because the 3D printing is, of course, a big part of it. But in the end, it's just a means to an end, and you have to adjust the pre-construction phase as well to optimize for 3D printing. All right. Conclusion. Well, we can do conclusions and Q&A at the same time. I thought it was a slide for conclusion, but that's fine. But the conclusion pretty much is what I said during the webinar as well, and all of my colleagues said as well. There's a lot of time, not just to be saved in the construction phase, but also in the pre-construction. And all these lessons that we have learned, the changes we have made, they are now, of course, part of our experience. And we have tools based on those lessons learned, which of course is very helpful. What you can see now on your screen is a couple, if not pretty much all, well, a couple of projects that we have done in the past. And we of course spoke about the Robust Villa, the University of Johannesburg House, and the Row House in Paraguay. Please focus the questions on those three, but if you have questions about any other project, that's fine as well. So let's see if there are any questions. Does the printer have extrusion cutoff for U-shaped design? Could you just print both pillars simultaneously? Adam, this printer specifically does not, because we can 99.9% of the time change the design in such a way that we don't need this. Also, it decreases your overall equipment efficiency because you have to stop printing, move it, start somewhere else. So we actually focus on designing the printed elements in such a way that we don't need it. For our gantry model printer, which of course is responsible for a lot bigger prints, we do have this cutoff / start stop system. Yeah, thermal bridge requirements. I thought was listening to everyone speaking. I say, hey, we have one thing in common. For all of them, there's no continuous installation. We will probably have talk about this in the future, but we have done quite some projects and we have some principles that rely on this. So maybe Quinten can, besides share the presentation, which will, I don't know if the presentation will be shared, but it will be on YouTube and on our website, so you can always watch it back. I believe you will also share the presentation, right?
I will with the ones that ask me, but
Okay.
normally we just share the video and not the slides.
Well, you can always get in contact with me. I'll talk about that towards the end of the webinar, but it's via the contact form on our website. And there I can share some documents with you explaining how we overcome the thermal bridging and the continuous installation. Let's see. How do you deal with the vertical seams between the wall segments? Do you leave a gap for caulking or mortar? Is there a continuous cavity for installation? Installation we just talked about, but maybe Leo, if you will.
Yeah, just activate the camera. Okay, I'm back on, on the stage. Yeah, of course, we have to seal that connection between the different wall elements. What we do is indeed using traditional products. So what we need to ensure is, as in any other joint, for water tightness and air tightness. So what we work with is usually, of course, caulking for the air tightness part on the inside, but what we use is usually also tapes, basically sealing tapes that allow us to just take into account different tolerances that might happen while printing, and also, of course, the shape of our wall, which is not exactly smooth.
Yep.
But yeah, so we use traditional products for air and water tightness.
Yeah, and it depends on local regulations, of course, what we and local availability, right? Yep. Consider printing with earth materials. Yes, however, we are in the business of trying to be faster and more affordable. Of course, more sustainable, but there's different ways to be more sustainable. And if you want to be faster and more affordable and get your buildings actually permitted, it's quite hard, for example, to do construction with clay. Which is, of course, a nice material to print. A lot of companies can print with clay, but it's very hard to make structural parts out of it, and it's even harder to get it permitted. So, like I said earlier in the webinar, we want to revolutionize the construction industry, but we have to do it in small steps so that the permitting process, the structural engineers, and the general contractors, we can take them with us. Otherwise, the gap will be too big between our technology and the current status of construction industry, which is why we don't focus on printing with earth materials. I hope that answers your question, Jerry. What we do, however, or our partner does, is print with geopolymers, which is also a very nice, almost CO2 neutral material, which can be printed. We also have worked with a partner to put wood chips in our concrete, or, for example, biochar in the concrete. We do some material research in that regard, but we keep it in the concrete or geopolymer range, stuff that's easily permitted and strong enough, because clay is often not strong enough to get that. Exactly, geopolymers are next gen. Yep, and our partner prints with it. Very, very pretty. What we're currently printing with is a mortar. Yep. I believe that is pretty much it. I believe I have all questions answered. So in that case, I would like to thank everyone for being here and thank all my colleagues for their part in this webinar. Thank you very much, guys. Of course, as always, you're welcome to visit our academy or our the website to look at the other webinars that we've done. You can check out our academy where we have some courses. Some are unfortunately paid courses, but there are some free courses there as well if you're interested in learning more about 3D printing, and then how to get in the library. We talked about that quite often. then how to get in touch with us if you are indeed still interested, or even more interested, or for the first time interested in speaking with us. If you're interested in us looking at a project for you, or if you're interested in buying a printer, you can reach out via the contact form on our website. For other questions, you can of course also use this contact form. There's a couple of options that you can select, and if you use the I want to buy a printer, or I want Siebert to buy my print my project, then you will get directly in touch with me, and I can answer any further questions that might come up. The next webinar, let's see. Oh, the next webinar is very exciting because I believe we will be doing that webinar together with Jared Gross. That's fully confirmed. Great. So many of you might know Jared Gross is quite famous in the 3D printing ecosystem on YouTube, and he will be joining us for our next webinar. So that's going to be exciting as well. I believe that's it from my side. Again, thank you guys for your contribution to this webinar, and thank all of you for being here. And I look forward to you reaching out to us, or look forward to seeing you in the next webinar. All right. Thank you, guys.